Hello my friends, welcome to this new tutorial, and now we're about to train the SVR model on the whole dataset after a successful data preprocessing phase with your new experience in feature scaling, because now you can handle very well all the different situations. Alright, so let's train that SVR model on the whole dataset, of course, because we did not do a split of the dataset between training and test sets. So there you go, let's create a new code cell. And now let's build, of course, in the most efficient way, the SVR model. So we're going to build it with scikit-learn, of course. I remind that scikit-learn is the best data science library, excluding deep learning, because of course we have TensorFlow and PyTorch. But for any machine learning model that is not based on neural networks, well, scikit-learn is definitely by far the best data science library. And for what we are interested in right now, you know, the SVR model, well, we will build it with a class called SVR, as simple as that, which belongs to a module of scikit-learn called SVM. And so we have to start here from first scikit-learn to access the scikit-learn library, from which we're going to get access to that SVM module. So that's the module from which we're going to import that SVR class. Perfect. Now we have the class, and you of course know the next natural step. Anytime you import a class, the next natural step is of course to create an object or an instance of this class, and we're going to call that object regressor, just like before, because this instance or object of the SVR class is nothing else than the SVR regressor itself, you know, the support vector for regression regressor. So regressor, and then of course we are going to call this class SVR, add some parentheses, and this time we have to input a parameter. Because indeed, remember in the intuition lecture of support vector regression, and you will also see in the intuition lecture of the support vector machine in the next part 3 classification, well, you actually have what we call kernels, which can either learn some linear relationships, and that's the linear kernel, or nonlinear relationships in your dataset, which are the nonlinear kernels, such as the RBF radial basis. I will actually show it to you right away, you know. That's the Gaussian RBF kernel, which is given by this formula, and I can actually show you the plot of that kernel. Here it is. So that's the Gaussian RBF kernel. And then you also have some other kernels which I've prepared here on this great website showing clearly the different kernels of the support vector machine, but also the SVR, because the SVR is nothing else than a support vector machine model for regression. So let's see, here they are. There is the polynomial kernel, adapted for nonlinear datasets. You have the Gaussian kernel, which has the classic Gaussian function, then the Gaussian radial basis function, the most widely used one, and that's actually the one we will use. Then you have the Laplace one, the hyperbolic tangent kernel as well, that's a popular one. Sigmoid, well, you have all of them here. And so if you're curious, yes, you can have a look at them, but the one we will use for our implementation will be, and that's the one I recommend each time you experiment with an SVR model, and that's the radial basis function kernel, the RBF kernel. And that's exactly what we have to input here in our parameters. And so the name of that parameter is kernel, so that's the name of the parameter, and then the value we want for that parameter, which you know corresponds to the radial basis function, has the code name in quotes RBF. And that's it. That's only what we have to input here. So that basically creates the SVR model with the radial basis function kernel. And so now that means only one thing. That means that we already have built the model. We already have the SVR model itself. And so now the last final natural step is to, of course, train that regressor on the whole data set, right? Which is also the training set. Okay, so let's do this. You know exactly how to do this. You know, from this point, it's exactly the same as before. You know, the same function, which is of course the fit function, and which will train this SVR model on your whole data set, right? To learn the correlations between the position levels and the salaries, and all this done with the radial basis function kernel. All right, so let's do this. Let's train our regressor. So we take our regressor object first, and as usual, we add here a dot, and then the fit method, which takes as input this time not xtrain and ytrain, because we have not created a separate training set, but of course this time the whole data set which remember was feature scaled, both on the matrix of features x part and the dependent variable y part. And so that's exactly what we have to input here, both x and y. And that's it. Congratulations, now you know how to build and train an SVR model after a successful data preprocessing phase, including a special feature scaling. Alright, and so now we have a very interesting next step. It is the step where we predict the new result. And this next step is very interesting because it will teach you how to reverse the scaling of your prediction. Because you will see that when we apply the predict method to predict this new result, well, it will be returned in the scale that was used for y, right? The new scale of y after it was transformed. And so we'll have to reverse this transformation, we'll have to reverse the scaling in order to get the original scale of y, and I will teach you exactly how to do it in the next tutorial.